Java has many important features which made Java a great programming language. But out of all those important features, one most important feature is platform independent. When Java was released in the market, many people started adapting to Java just because of platform independence. So let us have a look at this. What is platform independent and how Java became platform independent and what exactly platform is. Let us know what do you mean platform. If anyone wants to execute any program, we must have a platform for us. What is a platform? Generally we think platform is some machine, physical devices of it. Let's say I have a sample.c file which is a C program. My aim is executing that. If I transfer this file to the CPU, which is the machine, it cannot execute it. No human or a program can directly interact with any of the physical devices of a machine. It will not happen. Then how to execute a program? Any human or any program can communicate only with some interface called operating system. This operating system will have set of predefined programs which are helpful for us to make use of any of the physical devices on the machine. So to run any program, both operating system and processor are responsible together, but not processor alone. So the operating system and its architecture both together we call it as platform. So when my aim is executing this C program, I had to give it to the operating system after converting that C programming into machine understandable format. Now I convert the C instructions into my local machine understandable format. This exe file has binary code. This will make communication with operating system. So it is making some system calls to this operating system. These system calls are for this specific operating system. Different machines may have different operating systems. They are like Windows, Mac, Unix, Linux, and many other flavors are available. Different pairs of operating system and processor together create a new platform or architecture. Before we understand how Java is platform independent, let us have a look at other programming languages like C and C++. What are they doing and why are they not platform independent? So I have a machine with me and I have a platform on it. My machine's platform is your Windows operating system and I have a processor. Now I try to write some C program, I have to execute it. Now I try to give the C program to the platform. We know that this platform cannot execute it as a machine can understand only binary language which is zeros and ones. So we know that some translator is required who is compiler in case of C programming. C compiler, in short we call it as CC. Now I submit sample.c program to the C compiler. We know that C compiler job is converting C programming instructions into machine understandable format and place it into a new file by the name sample.exe. This file has Windows calls. It is converted into native code. The native platform is Windows operating system here. Now I submit this exe file. Windows operating system can go through all those statements. The program will be executed and we get desired output. Now I have 3 different clients available. All of them are also interested to execute my sample program. So I had to transfer my program. We know that we will not transfer the source code which is sample.c. Instead, we are supposed to transfer only sample.exe. So I am giving sample.exe to the very first client. My exe file has native code that is for calling Windows, but the target machine has Linux platform. As their platforms are different, it cannot be executed. Now I submit this program to the other machine which is Mac. Even here it is cross-platform, this cannot be executed. Then I transfer the same file to the third client. Given program has calls for Windows and the target platform is also Windows. So there is no issue, this program will be executed. So the sample.exe can be executed only on that platform which is same as my platform. This is where we can call it as platform dependent. So when you consider C or C++, these are platform dependent programming languages. This is the limitation for C or C++ programming languages. Now let us understand how Java is platform independent. I have a machine with me. My machine has Windows operating system and some processor. This time I'll write some Java program which is sample.java. As usual, I try to submit this program to my platform. We know that this cannot be executed as machine understand binary code but the file has high-level programming language. Here we need a translator who is Java compiler. In short, it is Javac. Now I submit sample.java to the Java compiler. Now Java compiler job is converting Java program into some other format. In case of C, the C compiler converted C programming into local platform understandable format, which is directly machine code. But here in the case of Java, the Java compiler is converting Java program into some intermediate language which is called bytecode, and it will be placed into a class file. The Java file is human readable but not machine understandable. But when it comes to class file, this is neither human readable nor machine readable. If I submit this bytecode to my local platform, this cannot be executed. Again, I had to convert this bytecode into machine understandable format. For this purpose, Java has given JVM. JVM is Java Virtual Machine. It has got some interpreter and also JIT compiler. Now this bytecode will be submitted to JVM. Now the JVM will convert the bytecode into machine understandable format through its interpreter. So this can be executed successfully on my machine. So in case of Java, for compilation it is using Java compiler. For execution it is using interpreter, which is JVM. So Java uses both compiler and interpreter together for developing and executing a Java program. If somebody's aim is only executing a program, that is like every end user, they just need JVM but they don't need Java compiler. We can get Java compiler by installing JDK software on our machine, and we can get JVM by installing JRE. So the developer need both JDK and JRE, but in case of end user, they need only JRE. We have 3 different clients with 3 different platforms. I had to transfer my program to those clients for execution purpose. Now I had to transfer the Java program. Here I don't transfer source code which is sample.java. Instead, I had to transfer sample.class which has bytecode. So I'll be giving class file to the very first machine which has a Linux platform. Every target machine, whoever is trying to execute any class file, they must have JVM on their machine. So they can download JVM from the internet. But here you have to understand, Java has released a different JVM for every different platform. So the first machine must download JVM related to Linux. Now we submit this sample.class to the Linux JVM. It will convert into its native platform understandable format and it can execute it successfully. Now I transfer the same class file to the other machine which is Mac. Even this Mac will have Mac related JVM. Now class file will be executed by this JVM successfully. And I also transfer to the third machine which is Windows machine. Even they must have interpreter which is JVM. Even here it will be executed successfully. So there is no issue irrespective of the platforms Java programs are executed. So this is what we call platform independent. So what made this Java platform independent is the JVM what we are installing on the machines. Java is platform independent, but JVM is platform dependent, as we have different JVM for different architectures. So Java came up with a slogan saying that write once, run anywhere. So the Java program developed on one machine can be executed on any other machine in the world. As these days we are developing many distributed applications and our application can be spread across the world through the network. So this is expected. Our programs can be and must be executed on any platform.